Hello students. Over here we are trying to review the diagnostic test that I've given you physically in class, right? So let's take a look at these questions and try to understand some of the key learning points that we need to take note of when we are trying to solve this type of questions, all right? So let's begin. So in question one, what we are trying to do is to actually simplify this algebraic expression into a single fraction. So what we have is actually two fractions and subtraction, right? So we learned long time ago from primary school that whenever we are trying to add or subtract two fractions together, one of the first technique that we're going to do is to make the denominator the same. Now, more accurate, we say we want to make the denominator the common, or if you want to be even more exact, we say that we want to make the denominator the LCM. So if you look at the denominators, the first fraction is 8, the second one is 4. So the LCM of 8 and 4 is actually 8, right? So the first fraction on the left, we don't have to do anything about it. Or the one on the right, how do we convert this such that the denominator is 8? Well, let's examine it closer. We can see that over here we have 3 over 4, right? 3 over 4. So we know from the big ideas of equivalent that 3 over 4 is exactly the same in value to 6 over 8. They are equivalent, right? So if they are equivalent, we can actually rewrite 3 over 4 to 6 over 8. Perfect, right? So now the denominators are common. We can put them together in this manner. Now, when we are putting two fractions together, there are a few things I want you to take note. Number one, it is the entire numerator of the first fraction minus the entire numerator on the second fraction. Therefore, it is actually a good habit, right, to insert the brackets around the numerator. Okay, so whenever you have a situation like this, if I got A over B minus X over B, regardless of what A and X are, okay, when we want to put them together, right? I would like you to have the habit, right? Remember, good habits are important to actually have them in brackets. Okay, why is this important? Because if we were to put them in this way, especially when we have subtraction, um, the thing is, if this is in the expanded form, if we were to ignore and not put the parentheses or the bracket, we are only subtracting the first term and not the rest. However, we are actually subtracting the entire numerator. So it is actually a good habit to always do this. So in this case, 4x minus y, I put them in brackets, right? Mathematically, it is fine to not do that, but I prefer to do that, and I hope it is a good habit you can cultivate. For the second one, I did not, but if you want, you can, okay? Because this is actually 6 times the bracket, right? So imagine if I just have a numerator where it is 6a. I treat the entire 6a as a single term, right? If it's just a single term, then okay, it's just like there's a number 5 here, you just minus 5. You don't really need to put a bracket around it. So in this case, I did not. However, if you actually expand this first and get 6y plus 6x, which is what you will get if you expand this, then when you bring it to the next step, you have to put the entire numerator in the bracket. If not, mathematically, you'll be incorrect, as I explained earlier. Okay, do take note about this. Now, so once we have this, the next step, we can expand it, okay, if you have not expanded it earlier. So by expanding this, negative 6 times y gives us negative 6y, negative 6 times positive x gives us negative 6x. So this is another portion that we need to be careful because take note that over here, okay, it is negative 6, right? So when we distribute it into the bracket, it has to be distributed to every bracket. So it's negative 6x over here. Okay. So finally, simplifying it, 4x minus 6x gives us negative 2x. negative y minus 6y, negative 7y. So this is the solution. Okay, so that's the first question. Now moving on to the second question. In the second question, we have a algebraic equation, right? And we are told to solve. So solving it means we are supposed to find the values of the unknown. In this case, it is x. So we are going to apply the same understanding as the earlier question, question 1, right? So I look at the denominator. The denominator here is 5. The denominator here is 2. The LCM of 5 and 2 is actually 10. So recognizing that this is actually 1 over 5, then with the x there. So 1 over 5 is the same as 2 over 10, right? So I have this portion over here. Now, over here, same situation, right? This is, if I were to treat this 3 minus x in this manner, I have a 1 over here, right? So 1 of this numerator over 2. So 1 over 2 is actually 5 over 10. So I can actually convert it in this manner. So that's how I obtain this, right? Now that the denominator is common, put them together like so, okay? If you want to put a bracket around here, you can, but as I said, if it's just one term, it's not necessary, but it is good if you want to keep out that good habit to help you to visualize how this thing works, right? So let me just clear this first, okay? So putting them together, now from here, same thing, expand. So positive 5 times 3, positive 15. Positive 5 times negative x is negative 5x. So we have this. Putting the like terms together, 2x minus 5x, and this is what we obtain, right? So we have successfully combine the two fractions on the left hand side of the equation into a single fraction. That's good, right? So once we obtain that, we can simplify it further. What can we do? Well, the denominator here 10, right? How do we clean it up? We multiply by 10 on the left hand side, multiply by 10 on the right hand side. So when we multiply by 10 on the left hand side, the denominator actually cancels out, right? So we obtain this. Finally, these are things that are quite straightforward. I'm sure you are quite comfortable doing this by now, right? Subtract 15, then divide by negative 3 to get our x, which is 5 over 3. Okay, so this is question number 2. Question number 3 tests some of our basic understanding of circle and square, right? So circumference of circle, okay, we know the formula, it is 2 pi r, right? 2 pi times the radius. And in this case, the radius is 4r. So we get the circumference of the circle. Now, as for the perimeter of a square is 4 times the length of the side of the square, right? Knowing that the area is 25 r square, the length of each side of the square, I just square root it to get 5r, right? Finally, because perimeter of a square have 4 sides, multiply by 4, we get the perimeter. Okay. Now, finally, we are told to find the difference and then to factorize it, right? So, I do recognize that some of the students may actually evaluate this, right? You take 8 times pi, and pi you use 3.142 or something similar, and you obtain decimal. We don't want to do that over here, right? It's mathematically you're not wrong. However, we have to understand the context of the question. That's why it is necessary to read the question properly and thoroughly before we attempt the question. If you read the question, it says to factorize. Whenever we want to factorize something, um, we will want to keep it, okay, in this form, okay, so that we can actually extract out common factors later to factorize cleanly. If you put it as a decimal, you find yourself into a situation where there's nothing to factorize, right? So we leave it alone. Okay, so that is something that we need to actually heighten our awareness of. Okay, so you do that. Okay, now the next thing we want to discuss is whether it is 20r minus 8 pi r or 8 pi r minus 20r. Again, we need to have a sense of awareness, those mathematical sense that pi is 3 point something, right? This is something we need to know. We know, but sometimes it's not at the forefront of our consciousness. So this is something that comes with a bit of experience. That's why as more exposure to this type of questions will help. So since 8 pi is no 8 times 3, 24, it's going to be more than 24. I don't even need to work it out, but I know that it is going to be more than 24, which is definitely more than 20. So when we are trying to find the difference in this case, we usually use the larger number minus the smaller number, right? So it will be 8 pi r minus 20r. And finally, to factorize, you have actually learned this previously, extracting common factor. The common factors is actually 4r, and this is what we obtain. Okay, so yeah, this one. Okay, so question number 4. Question number 4, the first part, applying the prime factorization on 525, we get this. Some of you leave the answer as 3 times 5 times 5 times 7. Mathematically, once again, mathematically, it's not wrong. However, some conventions when we are writing numbers in this way, we do want to write them in index notation, so 5 squared instead of 5 times 5, all right? Then the second part of the question tells us that 525k is a perfect square, right? And we're supposed to figure out what k is. So we have to have the understanding that perfect square, uh, from the perspective of index notation, is that the index, okay, the plural of index is indices, they are even numbers. Okay, so I can have 3 to the power 2 or 3 to the power 4 or 3 to the power 6. Okay, but in this case, we want 3 to the power 2 because we just want the smallest possible value of k and not the rest, right? There are actually infinite many possible values of k that will allow 525k to be a perfect square. We just want the smallest one. So just bump it up to 3 to the power 2. The power for 5 is already even, so that's fine. And then 7, we bump it up to 7 squared. So after we do that, by comparison, we realize that, okay, what's the difference between 525 and 525k? There's a copy, an extra copy of 3. There's an extra copy of 7. So quite naturally, k must be 3 times 7 to get 21. Okay. Now, for the third part of the question, there's another thing that we need to understand, right? So first of all, they tell us that 525, we know this, right? And this time round, they tell us that the highest common factor is 35, okay, which is 5 times 7. So what this means is that 35, okay, multiplied by a certain multiple should give us 525. 35 multiplied by a certain factor, okay, a certain multiplier should also give us x, okay. But we can't just anyhow randomly choose a number to multiply with the highest common factor to get x, right? There are some other things we need to consider. And the thing that we need to consider is that this number should not be found inside 525. Because if I take the highest common factor, right, and multiply with another factor that is found inside 525, then the highest common factor will include this factor, right? So if I say x is HCF times, let's say y, and y is a factor inside 525, then actually my HCF is not this, is not 35. My HCF will be 35 times y, right? So it cannot be inside 525. So this is one of the mistakes that some of you made. So let's learn from this. Therefore, we need to choose a number here that is not inside 525. Okay, so we also have the condition that the number should be in between. Let's see what I have here. In between 300 and 400. So we just test out some other prime factors that is not inside 525, and see whether it fits inside 300 to 400. And the next number that we test, okay, is a prime number. 11 is a prime number. We test it out. Hey, it works, right? 11 is not inside 525, and when we multiply it with the HCF, we get this nice number. We can test it back and find the HCF of 385 with 525 and realize that, hey, it's 35. So it's great. So this should be correct, right? This is fine. Okay, so this is the question number 4. Now moving on to question number 5. Question number 5, the question says that, okay, we have 84 children, and then we have a total number of people currently is 96 plus 84. We want to add some children, right? So that the percentage over here is 60%, right? At least 60%. So one thing we need to note is that, well, 60% is at least 60%. So the minimum number of x, okay, will make this exactly 60, right? So we don't have to worry too much. It is that straightforward. So we add the number of children by defining as x. So 84 plus x, this is the new number of children. And then, of course, we plus x below as well because this is the total number of people, right? So we add them in. So after that, it's just applying our algebraic technique to simplify this, okay? Simplify this. Cross multiplication, which is a technique that you have learned before, right? The numerator over here, multiply the denominator on the right side is same as the numerator here, divided by the denominator on the left side. Okay, expand, simplify, and we get the value that x equals to 60. Now, at this point, I just want to emphasize that when we are handling questions with context, it is a very important good habit to have a proper statement, right? We need to answer to the question. I do know that some of you did not do that in this round of in this particular test. I did not penalize you, of course. There's no need to, but I need to remind you, right? In a formal assessment, it is important to have this kind of good habit to actually write down proper statement, please, ladies and gentlemen. Okay, finally, question 6, what we have here? Well, the first part of the question is just trying to figure out how much you pay if you want to use the hire purchase scheme, right? So the down payment, okay, we have 1/5 of the original value, which is this. This is the original value, okay, plus 48 times you paid, and you paid this amount each time. Okay, so just add them up. Okay, most of you got this correct. So I don't think there's an issue with you guys here over here. Right. Second part of the question asks us to find the percentage reduction, right? Because the value of the car actually dropped year on year. So the original value is this. We already established that. So 1 year later, right? Depreciate by 10%. That means the value is now only 90% of the original. So this is after the first year, and then we do it again after the second year. We do it again after the third year. So after the third year, this is now the value of my car, right? For the car was from this. Okay, 3 years later, this is the value. So the reduction will be the original amount, right? The original value minus away the final value. So this is a reduction. And then we know the rules, right? To do this, okay, divide by, okay, over the original value times 100%, it works out to 27.1%. Okay, now again, it's a good habit to remember and keep reminding one another. Final solution for this type of questions, let's give it to 3 significant figures, which is a good accuracy to have. Okay, and that is the solution and the review of this particular diagnostic test. So with this, look through your scripts again and do your corrections and recognize, okay, what are the mistakes that you have made, and let's learn from these mistakes. Okay, well, have a nice day.